In this module, we are going to discuss about the conditional statements if else and switch. Basically, this is also a part of the modules which are basically based on the recapitulation of basic R. In this module, we will discuss some of the basic structures of if-else statement. With the help of an example, we will try to show you how this structure works, and we will also tell you the reasons why do we need to program with the if-else statement. Today I am here to have a detailed discussion on the conditional statements in R. Primarily, R offers us two of the conditional statements like if-else and switch. In some of our previous modules, we had discussed about the usefulness of several loops in R and how it works. Actually, the structure of different kinds of loops was already discussed and will be discussed several times during this course. But this module is primarily dedicated to conditional statements like if-else and switch. As we all know that if-else is a conditional statement. Now, let's see how it works. Actually, all kinds of loops including conditional statements were covered in your basic level course of R. Since this is an advanced one, so just consider this discussion as a recapitulation of the previous course on R. Anyways, let's start with the syntax of the conditional statement if-else. Once this basic structure is known, we can always do whatever we want to. Here, this is the syntax of if-else statement. Now have a close look at this. Here, what we are doing is that we are putting the condition we want to impose here after the first bracket starting after if. And then we are posing the conditional statement that if this condition is true, then execute something. Here we are incorporating the thing which we want to execute if the conditional statement is correct within a second bracket, just after the logical statement. So this part is pretty simple. But here comes the remaining thing. Here we are also including some added series of execution. Like here we are including the fact that if the logical condition does not hold, then what to do. For this, the else part is introduced here. In a similar way, here we are adding the part which will happen if the logical statement does not hold after the word else, and we are wrapping this within a second bracket. In this regard, this is worthy to mention that the second brackets are optional when you are using only one statement. As we had just discussed, here the most common test is the if command. If the tests pass, they result in true and otherwise false. So, if it passes, then R will give us the first thing of execution, and if not, then it will give us the second thing of execution. From the example given here, we may have a more clear view regarding the mechanism of if-else statement. So let's consider this example. Here we are showing just the if part. Our objective here is to print hello if check is equal to 1. So what we are doing is that we are putting the conditional statement that is check equals 1 after if and putting it within first bracket. as we know, since we wish to compare check with 1, hence we are using the double equal sign. Now, if this statement is true, what we do is we will print hello. So, here we are putting print hello after the conditional statement and within a second bracket. Again, here we may omit the second bracket because it's optional and it contains only a single statement. Here, since we had assigned 1 to the variable check, so the conditional statement turns out to be true and hence hello is printed finally. So, by now it is pretty clear how the if part works. Now the question is, why do we need else? The if then else statement provides a secondary path of execution when an if clause evaluates to false. That is, when the if statement fails, then only we need to look for the else statement. Otherwise, if it doesn't, then there is no need to search for it. Here comes another tricky and interesting example. Consider this. Here at first x is taken to be the sequence of 1 to 4. In this example, we are introducing the if-else statement within a for loop. Why we are doing this? The reason is that in the previous example, what we were doing is that we are checking only one conditional statement and stated that if this holds, then we are going to do this and else we will do this. But here we are going to check a series of logical statements which are obviously of the same type. But now we all know what is the structure of a for loop is. So we are not explaining that. We have exactly used the same thing here. Here for each of the values of I, which indicates the position of the values of the x, we are getting a number from the x vector. And then we are checking as we are directed that if that value is less than or equal to 2, then we will print yes, else no will be printed. So basically this xi less or equal to 2 part is the conditional statement here, and yes or no are the actions that are being executed. Here this is needless to mention that since 1 and 2 are less than or equal to 2, so we are having yes corresponding to that, and for 3 and 4 we are getting no since these two are not satisfying the condition. Now the problem which we just discussed took a bit of our time and the code is pretty lengthy. Now let's find out some method which can minimize our time as well as the labor included here. So what to do? Here comes the idea of the single if-else command. So let's see how it works. The syntax of the statement will be like this. Here at first we need to put the test you want to execute, then the true values should be given, and finally you need to give the true value as well as the false value. That is, if the test comes out to be true, then how R will show the result, and if it is false, then how to show it. And all the things should be put within a first bracket after if-else. Now consider this example. This will help you to understand the thing clearly. The same x is taken here. Now just putting the things following the syntax of the if-else loop, like put x is less or equal to 2 or x is greater than 4 in the place of test, then put yes as true and no as false value. By this way, we are actually getting the same result compared to the previous one, but with the minimal effort. Here are some of the signs of operators that we often use. We use this double equal sign when we try to say equal. One of the most common programming mistakes that one can make is to confuse the equal sign with the double equal signs. When we wish to assign a value to a variable or member, we use the equal sign. As for example, x equals 1 plus 3 would assign the value of 4 to the variable x. But when we wish to make a comparison, such as in an if-else statement, we use the double equals sign. A simple example would be the one we had given in the very beginning. When we wish to use not equal sign, we will use this sign that is given here in the slide. Similarly, for greater or less sign, we will use those two signs. For greater or equal to sign, we need to just add the equals sign after greater or less. For and, we need to use that and sign. And for or not, we will use these two particular signs. So by now we have learned a lot of things regarding the if-else statement. So here comes some of the applications of the things we have learned so far. Here, consider this problem. The problem is like, suppose x is a vector of first 10 natural numbers. Here, our objective is to find out the odd numbers using if-else statement. Now, we know that among 1 to 10, 5 numbers are odd and 5 are even. So, it is very easy to find out for us. Now, let's see how R finds it using if-else statement. Once we can solve this kind of easy problems, we can master the art of tackling even some trickier problems gradually. Here, let's consider the vector x containing the series of values 1 to up to 10. Here, we are assigning null values to the variable odd, and similarly, null values are assigned to the variable even as well. We know what the syntax of if-else statement is. So what we are doing is that we are putting the test in the first position, then the true value is there, and finally we are putting the false value. Here we know that if a number is not divisible by 2, then it would be regarded as odd, otherwise the number will be even. From the symbols described in one of the previous slides, by now we know that what a not equal sign is. So, we are putting the test to be performed, that is x not equal to 0 in the first position, and then the true and false values, that is if the remainder is not equal to 0, then odd will be the true value, and if it equals, then the true value will be even. So, odd and even are placed one after another here. So, this is how we can have the solution of our problem in a much simpler way. Now, let's deviate a bit further, and here our objective is to find some alternative ways of doing the exactly same problem without using if-else. Let's see how far we can proceed. Here, as we had done previously, we are assigning null values to the variables odd and even. Then, we are trying to use for loop to solve the problem. Now, we all know what the syntax of a for loop is and how it works. So we are just doing the following things. Since there are 5 odd and 5 even numbers within 1 to 10, so what we do is we are varying I to be 1 to 5 and taking odd I is equal to x of 2i minus 1 and even I is equal to those value corresponding to x 2i, and then we are having these odd and even values. So basically what would be the value, say odd 3? It would be the value of the 2 into 3 minus 1th value, that is the 6 minus 1 is equal to 5th value of x, which is 5. And the 4th member of the even set is 8. So finally we are having these odd and even values. Now another way of looking at this problem is that here we are assigning those values of x to the odd variables for which we divide it with 2 and the remainder will not be equal to 0. And similarly, we are assigning those values of x to be even for which we divide it with 2 and the remainder will exactly be equal to 0. So here is the series of x and y values among 1 to 10. So just note that how differently we can handle the same problem. Here we will give you some other problems of this type as well. Now consider this problem. It looks pretty similar with that of the previous one. Here we are asked to find out the odd numbers where we are given a set of values 6 to 20. So basically we want to find the odd numbers between 6 to 20. So let's see how to handle this problem. As before, we are storing the sequence of values 6 to 20 in the variable x. And since we are concentrating on the odd values, so the variable containing the name odd needs to be initialized as null. Here also we are using a for loop. Now the thing is that we are considering the numbers from 6 to 20. So altogether we are going to have 15 numbers to handle. Again, we are using the logic that if we divide any odd number by 2, then the remainder will be 0. So here, if the number we have chosen from 6 to 20 gives the remainder not equal to 0 when it is divided by 2, then we will assign those x values to y. And again, taking j from 1 to 7, we are getting the odd values by taking those values corresponding to y 2 into j. So by this way, we can also have the even numbers between 6 to 20. Now our next problem is calculating the median of a sample. Again, the problem looks pretty simple for small data if we calculate it manually. But R will help us to handle even a large amount of data and calculate the median efficiently for those cases. So let's see how it does that. To understand how the program works, you need to know what the ceiling function is. Ceiling is basically a single numeric argument that it returns the smallest integer larger than the parameter. For example, if we want to have the ceiling of 2.5, then we will actually have 3. If we like to have the ceiling of say 5.7, then the ceiling would be 6 and so on. Now let's go back to the problem. Consider some smaller sets of numbers. Like here we have 3, 9, 4, 6 and 1. these numbers are stored in X and we need to find the median of them. Then the question is how to tackle this problem. The simple idea is to sort the number firstly, then examine if the length of the numbers are even or odd. If it is odd, then the things will be simpler. In that case, we will consider that value to be the median, which corresponds to the middlemost value of the series. But the case is a bit twisted if the length is odd. In that case, what do? We will sort the values and consider that value to be the median, which is the mean of the two middlemost values of the sorted series. We are using this logic here in order to write down the program. Here in this program, what we do is when the length of X is divisible by 2, that is when X is even, then we are doing the first thing written here. That is, we are sorting the numbers and taking the value to be median, which is the mean of the two values. One is the value corresponding to the length of X by 2 in the sorted series, and the other one is the value corresponding to the 1 plus length of X by 2 in the sorted series. And if the length is odd, then the work is very simple. Then the median will be the value corresponding to the ceiling of length of X by 2. Here, since we have 5 numbers and hence the length of X is 5. Now, if we sort the series, then it would be 1, 3, 4, 6 and 9. And the value corresponding to the ceiling of 5 by 2, that is the value corresponding to X3 when X is sorted, is 4. So, 4 is the median here. So, we have already discussed a number of different kinds of example here. So, let's stop here and some more examples of these kinds will be discussed in the next module. So, from this discussion, we now have some basic ideas about the structures of the if-else statement. We had also given some of the basic operators which we often use in R programming. And we also show you how you can calculate the median of a sample. We can also find the odd and even numbers from a set of numbers. So we are stopping the discussion here, and this discussion will be continued in the next module as well, where we will show you some detailed example of if-else statement and also some detailed structure of the switch statement.